Welcome to aminacademy.com. And questions how, why, and what. Regarding that, let us ask these questions. Do magnets work in space? How the material get the magnetic power? Magnets, of course, can work in space. Magnets don't need gravity or air. Instead, their power comes from the electromagnetic field they generate all by themselves. Magnetism is everywhere in the cosmos, planets, stars, gaseous nebulas, entire galaxies, and the overall universe are all magnetic. Magnetic force is independent of the Earth's gravitational force. Therefore, a magnet will work in space. As the Earth is also a big magnet, which two poles, north and south, is to exerts a force on other end. So Earth also a giant magnet. Do magnets work in space? We'll discuss further detail. Yes, magnets work in space just as well as they do not do on Earth. Magnets are able to function in space because they generate their own magnetic field which is not affected by gravity or air. So the magnets can work in space anywhere. Here are some things to know about the magnets in space. Magnetic properties. Magnets retain their attractive and repulsive properties in space. The orientation of a magnet in space changes as the space station moves around the Earth. For example, when the International Space Station ISS is over the southern hemisphere, the south side of the magnet bar points towards Earth. Space exploration. Magnets are important tools in space exploration. For example, astronauts use magnets to hold cutlery on their trays during meals. Earth's magnetic field. The Earth's magnetic field can also affect magnets in space. The magnetic field attracts small charged particles which collide with atoms and molecules in the atmosphere, producing light. The materials gain magnetic power when the atom in their atoms spin in the same direction, creating a magnetic domain. So the materials gain magnetism. Look at here. This is the north and south pole of the bar magnet. Here, this is the loose and random magnetic domains. Here, effect of magnetization domains lined in up in series. Electrons spin around the nucleus of an atom, generating electric current and making each electrons act like a microscopic magnet. Magnetic domains. In most materials, electrons spin randomly, but in magnets, the electrons group into magnetic domain. Ferromagnetic material. When the spin of the electrons align spontaneously, the material is called ferromagnetic. That is, iron, cobalt, and nickel are examples of ferromagnetic material. Paramagnetic material. Some materials become magnetic when placed in an external magnet field. The alignment of the electron spins vanishes once the external field is removed. It's a paramagnetic material. You can also make a magnet by wrapping wire around an iron nail and connecting the ends of the wire to a battery. The electricity passing through the nail magnetizes it. How the electromagnetic created? Look at here. Here, an electromagnetic is created by passing an electric current through the coil of a wire wrapped around the ferromagnetic core, such as iron. Here, ionic core. Look at this is when it is supplied electricity inside. Then this magnetized. It's called electromagnetic field. The blue lines are magnetic field line. This yellow lines are electrical current direction. Wrap the wire, insulated copper wire around an iron core is the shape of the solenoid or U-shaped. Connect in wire. Connect the ends of the wire to power source such as battery. When the current passes through the wire, it creates a magnetic field around the core. The strength of the magnetic field depends on the amount of current and the number of turns of the wire. That means if the number of wires are passing through current is more, the magnetism is also more, and vice versa. The magnetic field disappears when the current is turned off. The magnetic core concentrates the magnetic flux, make the magnet more powerful. Earth is our giant magnet. The Earth is our giant magnet because the Earth's core generates a magnetic field and the crust has some permanent magnetization. The Earth's magnetic field is called the magnetosphere and it's strongest at the poles. The Earth has north and south magnetic poles similar to a bar magnet. However, the Earth's magnetic poles are not the same as the geographic poles. The compass needle points the Earth's magnetic south pole and is the geographical north direction. This is because of the Earth's magnetic south pole is considered as the geographical north pole and vice versa. What is solar wind? The Earth's magnetic field deflects solar and wind towards the Earth's pole. This deflection causes the aurora, a light show that can seen from space. Magnetic reversal. Geologic records shows that Earth's magnetic field has reversed in the past and that these reversals only take hundreds of or thousands of years. Earth scientist William Gilbert first proposed that the Earth is a giant magnet in 1600. He used a magnetized sphere called a terrella to demonstrate that a compass needle always points north south, such just like it does in Earth. So far, we discussed about the magnet, that is a permanent magnet, electromagnet. Earth is a giant magnet like. We have done. Please subscribe our YouTube channel.